Hello. In this video, we are going to be covering the laws of logarithms. So take notes. 4.4 laws of logarithms. Okay, so here are some laws, some properties, some laws. So let's start by letting a be greater than 0. A is not equal to 1. And also let's let A, B, and C be real numbers as opposed to imaginary numbers. So be real numbers where A is greater than 0 and B is greater than 0. Okay? All right, so if these conditions are true or hold true, then we have the following laws. All right, so this first one. If you're taking the log of a product, okay? If you're taking the log of a product, then that is the same as taking the log of A plus the log of B, okay? And make sure that you understand that this goes in both directions, okay? So if you have the log of a product, you can write it as the sum of two logs. If you have the sum of two logs with the same base, you can rewrite it as a single log. Okay, so you can go both directions. And sometimes you want a single log. Sometimes you want to split up the log. Okay, so sometimes it's nice to have it written like this. Sometimes it's more convenient to have it separated. Okay, just depends on the situation. All right, number 2, log base A of a quotient, A over B, is going to be equivalent of log A minus log B. Okay, so the log of a product can be written as a sum. The log of a quotient can be written as a difference. And again, make sure you can go this direction as well, because sometimes if you have the difference of two logs, sometimes it's better if you have it written as a single log. And you'll see that when we start solving log equations. Okay, and our third one, log base A of A to some power C. Okay, so here what happens is if you're taking the log of something that's raised to a power, that's going to be equivalent to taking that power down to the front and multiplying with the log. Okay, and again, when we start solving exponentials, this is going to come in handy. Understanding that, oh, if I'm taking the log of something to some power, I can bring that power down to the front. Okay, so these are the 3 properties. Very important to be successful in the next section. You have to know these properties. Okay. All right. So let's practice using these. All right. Use the laws. Use the laws to evaluate each. Okay. All right, so suppose that we have this one, log base 4 of 2 plus log base 4 of 32, okay? All right, so according to the laws up above, if I have a sum, I could rewrite this as a single log of a product, 2 times 32. Well, 2 times 32 is 64. And here, 4 to what power will give me 64? 4 to the third power. 4 times 4 is 16. 16 times 4 is 64. Okay, let's take a look at another one. Log base 2 of 80 minus log base 2 of 5. So here, even this one clearly 2 to some power is 5. That's not something you can do in your head because it's going to be some decimal number, right? Because 2 squared is 4. That's too small. But 2 cubed is 8, and that's too big. So it's going to be somewhere between 2 and 3, 2 point something, right? Okay, so we can't even really do this in our heads. Okay, but according to the laws, if I have the difference, I could write this as a single log of a quotient, 80 divided by 5. Okay, and 80 divided by 5 is actually 16, and 2 to the fourth power is 16. So my answer would be 4. Okay. All right, go ahead and try this one. See if you can do this one. This one uses the third law. Okay, negative 1/3 log 8. Okay, hit the pause button and then come back. Okay, so this one uses that third property. So I'm going to go ahead and rewrite this as 8 to the negative 1/3. Okay, and 1/3 exponent is the same thing as the cube root. Okay, but then we have to take the reciprocal of 8. Okay, all right, so I take the reciprocal of 8, and now I can take the cube root of 1/8. And so that is going to be 1/2. Okay. All right. Excellent. Oops, actually, that's going to be log of 1/2. We didn't finish this. 1/2. And then using that in your calculator, we will have negative 0.301. Okay. All right. We use those laws to do expanding. Here, let's go back and look at them before we start these next examples. Okay, so we use these laws to do two things: to take a log and expand it, or to take an expanded log and condense it. Okay, so let's take a look, which is why you need to be able to go back and forth. All right, expanding. And combining. Sometimes you'll see in other books it's called condensing. Okay. Expanding and condensing, expanding and combining. Okay. All right, so let's use the laws to expand each. Use the laws to expand each. All right, suppose that I have this log base 2 of a product. Okay, so here we said if you have the log of a product, then you can write it as a sum. So let's go ahead and do that. So that would be log 2 of 6 plus log 2 of x. Okay, and then that's it. That's all you have to do. When they're asking you to just expand it, this is what you do. You expand this. You went from a single log to 2 logs. Okay, let's take a look at this one. Suppose that you have log base 5 and you have x cubed y to the 6th. Okay, so here again you have a product. Okay, you have a product, so we can go ahead and write this as a sum. Okay, but then we also have these exponents, so I can bring those exponents down. That's that third property, that third law. So 3 log 5x plus 6 log 5y. Okay, and this would be your answer. I guess I should maybe box my answers. Okay, this would be your final answer here. Okay, if you have more than 3 things you're taking the product of, like let's say you're doing log base 3 and you have, let's say you have x squared, y cubed, z4, right? This is still a product, so you can write all of these as a sum. So you can say log base 3 of x squared plus log base 3 of y cubed plus log base 3 of z to the 4th. And then all of these have exponents that you can bring down to the front. So 2 log 3x, 3 log 3y, and 4 log 3z. And this would be your final answer. Okay. And if I had some more here, if I had x squared y cubed z4 w to the 7th, then I would tag on plus log base 3 w to the 7th. But then I would bring that 7th down to the front. Okay. Let's take a look at this one. ln of AB over cube root of C. All right, so we got all kinds of things happening here. We have a product here. We have quotient here. So all the quotients will be subtractions, but we only have the quotient of this, okay? So we have ln of, so you can think of it like this, ln of AB minus ln of cube root C, right? And then this one, you can break this up because that one is a product. So now we can say ln of A plus ln B. And then here, we don't normally leave the radicals. We usually rewrite these with exponents like that. And then we bring that exponent down to the front. Okay. All right. And if you have, just like products, if you have several products and you have several quotients, like let's do one like this. Let's do x here, and you have y squared z cubed here. Okay. Then again, all of the quotients will be negative. Okay, so all of the quotients will be negative. So here we'll have log base 2 of x, but then we'll have minus log base 2 y squared and minus log base 2 of z cubed, because both of these, y squared and z cubed, are quotients, right? So all the quotients will be negative. Okay, and then we'll bring down the exponents. So log base 2 x minus 2 log 2 y minus 3 log 2 z. Okay, so that's just something to keep in mind. Like right here, make sure that if you have any radicals that you rewrite them in exponential form. Okay, all right, let's go the other direction. Let's go ahead and do some combining. All right, use the laws to combine each and write as a single log. Okay, so again, depending on the problem that you're working on, it might be more beneficial to have it expanded like this, or it might be more beneficial to have it condensed like this. Okay, so we're going to be condensing. So we're going to try to write it as a single log. That's this. Single log, one log, not three. Okay. All right. Let's take a look at this one. Suppose I have this 3 log x plus 1/2 log of x plus 1. Okay, so I have these coefficients out in the front, so I'm going to go ahead and write them as exponents for these. Okay, so I'm going to rewrite this as saying log x cubed, and I'm going to rewrite this one as saying log x plus 1 to the 1/2. Okay, all right, I have a sum. I have a sum, which means I can write this as a single log of a product, x cubed times, and now if you want, you can bring back the square root now that we're going the other direction. Okay. And this would be my final answer. Okay. Suppose that I have this here, 3 ln p plus 1/2 ln t minus 4 ln t squared plus 1. Okay. All right, so again, here I have all of these coefficients. So I'm going to go ahead and put them back in their exponent positions. So this is p cubed. This is ln t to the 1/2, which is the same as square root, minus ln t squared plus 1 to the 4th. Okay? All right, so remember what we said about all the quotients are negative. So anything that's negative is going to be a quotient. Okay? So single log, and we have p cubed, t to the 1/2, that's the same as square root of t. And then this one over here is negative, so this one's going to be the quotient. Okay, and that would be the final answer. Okay, all right. If you do plenty of these, you'll develop a rhythm, and you'll be able to say, "Oh, these are pretty easy," but you have to get used to it. Okay. All right. One last thing here: change of base formula. All right. So if you noticed on your calculator, we only have the common log base 10, and the natural log, right? And so you must be wondering, how do I do how do I find log base 2 of 5, right? Okay, so we use the change of base formula. Okay, so the change of base formula says that if you have a log with some base and you're taking the log of something, well, if you don't have it in on your calculator, then you could use this change of base formula, which allows you to change the base. So if this is like base 2, but you don't have log base 2 on your calculator, then you can use this to change the base. Okay, so in order for you to change the base, you would go ahead and rewrite this problem as the log, any base you want, of x over the log, any base you want, of b. Okay, so that's how you would do it. Okay, so this is the change of base formula. So if you have to punch in log base 2 of 5 on your calculator, you don't have a base 2, you don't have this, so you would use this formula. Okay. All right, so let's go ahead and try one. Okay, so if I have log base 8 of 5, then if I look on my calculator, I will see that I don't have a log base 8, so I would use my change of base formula. The only base I do have on there is log base 10 and log base e, right? Common log and natural log. And it doesn't matter which one you use. You can use either one. You'll still get the same answer because it's a ratio. Okay, so I'm going to use the common log. So I'll use the common log button, and I'll do common log of 5 over common log of 8. And when I punch that into the calculator, because I'm able to now because I do have log base 10, then I'm going to get 0.77598. Okay. Try this one on your calculator. Make sure you can do this. Okay. Log base 9 of 20. Okay. Punch that into your calculator and see if you get this number, 1.36342. If you get this, then you're entering everything correctly. If you use the common log, great. Now go ahead and try it with the natural log with base E, ln. So try it with the natural log, and you'll see you're going to get the same answer whether you do log 20 over log 9. You're going to get the same thing if you use ln, natural log 20 over ln 9. Okay, but test it out. Don't trust me. Go ahead and punch this one in, and then punch this one in, and you'll see both times you should get that. Okay. All right. Excellent. That is the end of 4.4. If you have any questions, make sure you message me or email me. See you next time.